Okay, hi folks. I'm really happy to be here because I talk a lot about security stuff, crypto stuff, and so on. But this is the first time I'm able to present a talk about the zero-knowledge architecture or zero-knowledge applications dedicated to the Node.js ecosystem. So it's really nice for me to be here with you. Is there anybody that already know about the zero-knowledge architecture, what it is and how it works, or not at all? No one. Yeah. Cool. Welcome to the new world. So, I'm really sorry for my voice. I'm a little bit sick and it's not really good, but we'll make some try. So, technology doesn't work still, but it will work at one time. So, the first one, why do we need a zero-knowledge architecture? Because we need to do some protection. We need to protect our users' privacy, and we need to protect our users' data. Why? Because our data is more and more sensitive, and we, as developers, our architects, we need to preserve our users' privacy. So we need to protect how the data flow. In fact, we need encryption. And when I say that we need encryption, it means that we need some way to protect the data by encrypting it and not to be able to decrypt it anywhere than in the client itself. So the server don't have to be able to decrypt any kind of data. The second thing is that the backend has to be agnostic. Why? Just because whatever you want to do, if the encryption remains on the client side, you don't have to deal with it on the backend. So you can develop your backend in zero-knowledge architecture in any language as you want. Just Node.js is probably one of the best to do it. Why? We will see it. But we need to stick to the venerables HTTP verbs. We don't have to do more. Just because they are here to handle most of the problem and the issues we will have in the zero-knowledge architecture. So, what zero-knowledge is, precisely? It's a design pattern that enforces our users' privacy. It means that we will never deal with the user's plain format data. We will encrypt it at any point where the data flow. The only way, the only moment when the data will be in a plain format is in the client itself. And that's all. So we need end-to-end encryption. We need to encrypt the data in the client, and we need to decrypt it on another client or another user's client because you want to share some blobs of data between your users and your clients. It means that we need to have asymmetric keys at each end for the sharing. A quick reminder about asymmetric encryption. It means you have two keys. They work by pair, a private key and a public key. You encrypt the data you want to send with the public key, and the data is decrypted with the private key associated with the public key that you used to encrypt the data before. Right? Okay. After lunch, this is not really easy, I know. I will try to make it more fun. But problem is, asymmetric encryption is really slow, and we need to fasterize it. So we will rely on symmetric ciphers, and we will encrypt the data with a symmetric key, which is the same key that we will use to decrypt it. And the only part we will encrypt using an asymmetric cipher is the key itself. Bonus point, it will prevent some cryptanalysis because it allows you to just generate a new key, a new symmetric key for each new blobs of data. So it's far more complex to perform some brute force and cryptanalysis on the content because this is never the same key that will be used at each new blobs of data. So what are the backend roles on this kind of architecture? First one is to store and to return the encrypted data. Right, it's just here to pass the data between the clients. It will manage the public keys, only the public keys, because private keys are private, they are in your pocket and you never show it to anyone. And the associated tokens. It will probably deliver certificates because crypto peoples are smart peoples, and if you want a real protection on your data, you will probably rely on certificates rather than on passwords because they are more robust with the X509 standard. So it will deliver and issue some certificates, and it will maybe invalidate some payloads because when you share some blobs of data with a third-party application or another user, you probably don't want to put it to him or her for any time, and you want to expire your blobs of data at some point, and this is the role of the backend. Basically, the workflow between a client and a server in a zero-knowledge application is this one. First, your client will register on the backend. It will open an account on your backend, and it will get the root certificate hosted by the backend to issue some personal certificates inside its client. Then it will generate its key pairs, protected by the previously generated certificate, posting the public keys to make them available to anyone on the internet to share the content and the data with, and probably posting also some hashes. It will steal the client, encrypt the data with a rapid key, and sign the payloads to be able to validate them and to be sure that they are not corrupted at some point on the server, and put that on the server, and then the server will just validate the timestamps, validate the signatures, and returns the content, returns the data, and delivers the data. That's so. So what are the expected backend behaviors to make them available? First, we need to have some kind of authentication, because we need to open accounts, we need to manage some users on the backend, so we need to identify them, to create eventually some kind of accounts, and to link the data between the different accounts. Because if you want to share some kind of blobs of data, you want to precise recipient ID, so you have to link some kind of blobs of data with some kind of users, and this is a big documentary structure. We will rely, because we are still smart, on JSON Web Tokens, which are the future of sharing sensitive information between your client and your backend without relying on session, on cookies, and so on. So you just have to manage some tokens, and this token is signed, maybe encrypted, and contains the relevant part of your users, its ID, its permissions, its role, and so on. We will put in it some keys, some souls, some params, the chunks of data, and so on. The backends need to store the data and probably to store it in a document-oriented database, just because when you want to store this kind of information directly on your backend, you are storing some blobs of data that belongs to a user. So it's a definition of a documentary structure. You have one document per user, and you have the blobs of data associated to it. We need to do some keys management, so certificates generation, some key storage. Probably you want to rely on an hardware secured module, which is an hardware associated to your server, which is here to perform some signature verifications in black box, so it doesn't expose your keys and your server keys to the rest of the file system, which is a protection that can be mandatory in some kind of context. If you want to do it in the best way, in the best possible way, you want to distribute it, or you want to federate it, so you could rely on some queue messaging solution to distribute it, to scale it, or to rely to ActivityPub to federate some instances of your backends to share the data between the different users. So the workflow from the backend side is I create a new user, I return a JSON Web Token, I handle all posted chunks of data, and I'm allowed to patch them on the backend side. I check the signature and the expiration part, and I return it, or an error code if there is some problem during the process. That's all. Quite simple, yeah? OK, cool. So build it with Node. So why using Node? For all the reasons we said in this room since this morning, because it's fast, because there is an event loop, because, OK, this is not multi-threaded, but who cares? Because it's pretty elegant, because we've got the modules, because we've got our lovely NPM registry, and we are able to aggregate some blobs of code to build some complex application with just in a snap, because it's JSON native, and what's best to deal with some JSON data that languages that invented JSON, so cool. Because it's resilient, and probably the best one, because it's the same as the front-end part. When you are working on zero-knowledge application, you have to deal with cryptography, and a lot of cryptography. Even when you are doing some signature and signature verification. If your developers that are working on the client side aren't able to work on the backend side to just check or verify that the signature system is the same one on the client and on the backend, or probably working on the same shared library, you have to work in the same language. And JavaScript is embedded in many things, even on mobile, even on progressive web apps, even on desktop. So JavaScript is probably the best option to work for cryptography nowadays. OK. And working in a backend compatible with JavaScript is probably the best choice that you can do. So for the server part, I rely on Restify, which is a framework that allows you to develop some REST API backends. It is dedicated to that, and it does it very well. It has handler chains, pre-handlers, hypermedias, which is really useful when you want to link some blobs to a user and so on. You've got a system to do some versioning directly into your API, which is pretty useful because you don't want to do some cryptography without some solution to version your endpoint and allowing you to disable some part when they are corrupted or infected. And it's pretty smart at failing. So a simple Restify setup is just to require Restify, creating a server, declaring your endpoints, listening on your server, and you're done. Quite simple. Then you will have to rely on the certificates part with the X509 standard, which is one of the best ones to handle some certificates and to generate, to issue some certificates. We've got NodeForge, which is a full TLS implementation in pure JavaScript that you can embed directly in your server. It's full compatible for the certificates. So in my server, I will just import the NodeForge module, the PKI1. I create a certificate store. I import in it the root certificate. And then I can declare my endpoint. And when we post /users, so when I create a new user, I return to the user the created UID for the user and the certificate extracted from the store. So my client will receive its UID and the root certificate, so it is able to generate on its client side its client certificates to protect its private keys and so on. And then I can simply rely on it when I want to update my user. Second part, my user has the root certificate, can generate its private keys and public keys, and then he patch its own profile on the backends, pushing its public keys and pushing the hashes corresponding to the private keys on the backends. And everything is stored on the backend, and that's all. For the storage, I rely on the venerable MongoDB or even CouchDB sometimes. Even on the always on documentary structure, which contains, but is not limited to, the UID, the username, the password hash, signature source, the various keys, public keys for encryption and for authorization, the certificates, and a collection of items that are just the blobs of data I pushed on the backend to get them available to retrieve on another client. For the authentication part, when I create an account, I create it, I generate it on the backend, I store the hashes, the username, and so on, and I return the JSON Web Token. So it means that on my server, I've got two endpoints, one for the login, and one to get the JSON Web Token when I want to retrieve my content. And I use a passport solution, the passport framework in my Restify server. I just declared a local strategy. It just reads my user's collection. I will try to find the user and to verify the password on this user. And if everything is fine, I just return my users correctly. And I just rely on the middleware capabilities of the Restify server. So I just protect my endpoint using the passport authentication, and that's all. You can rely on a local strategy. You can rely on a browser ID and an open ID, on Auth0 if you prefer. There is something like 3,000 providers, 300 providers available for Passport, so you can connect it to almost anything else. You will have to protect your request between your clients and your server, so you need to do it using TLS, which is the S in HTTPS. Fortunately, is built in Restify. You just have to declare your certificates, and it directly exposes its endpoints behind a TLS connection, so it's fine. And you will protect the rest of the connection using CORS to prevent some cross-origin requests and steal the JSON Web Token for the authorizations. About CORS, there is a module for Restify. You just have to expose correctly the domains that are allowed to request on your backends and the various headers that you want to accept on the backends. So it's not complex at all. The various actions are so protected by and identified by the JSON Web Token, as I said a lot before. So I rely on a dedicated Restify module. I just use a server token, which is a shared secret, and between the backend and the clients. Then, same thing, using the middlewares in the Restify, I can just protect with the JSON Web Token my various endpoints, and it exposes inside my callbacks the content of the JSON Web Token associated to the user. So I can retrieve directly in my callbacks the UID, the public keys, and so on. So they are directly available. In these examples, I just protected my /items endpoint on the get method, where I just want the admin to be able to read the whole items available in the backends and not every user. What about posting items? When I want to post an item, my client will derive a key using an algorithm from the password, from its main password. It will post with a JSON Web Token to the backends to open a new slot for a new item. It will pass some salt params that are used to derive the key, and optionally an expiration timestamp. The backends will return the JSON Web Token and the new item UID, and then I just have to patch it right after. This is just like that. You just get everything in your post request, so the various parameters, you store it in your backend, you return the UID, and then you are able to patch your payload directly in the new item slot open on the backend. which means you will pass a payload with the encrypted data and the wrapped key and optionally a timestamp and a signature. Signature allow you to check that the payload wasn't altered at some point. If someone, some attacker, want to modify the content of the payload or modify the expiration time, the signature will be invalidated. And because the signature is generated using the private key that is in the client itself and only in the client, you can't generate fake signature. So it's a security measure. In my server, I will just put my, my payload for my dedicated UID. I will first check if the data isn't already available. If so, I just throw an error because I don't want to override an existing data in my backend. I will extract from the request body the timestamp and the signature, and I will rely on the crypto node module. I will just generate a verifier with a dedicated algorithm, and I will check the signature, which is just a signature on the concatenated payload and timestamp. If the signature failed to verify, then I throw an error. Otherwise, I save it on my backend, on my database, and just return the correct code. Getting users is exactly the same thing. I just want to rely on passport and get the hypermedia links that allow me to get the list of items. So I protect my endpoint with passport. I will perform hypermedia's link generation directly in my result, my returning result. And I will generate a token using a JSON Web Token module. And I will pass in it my user ID, its status, and eventually an expiration time, and I pass the token directly. So if I ask for a user, if I get a user, and I'm allowed to access to this user using the passport protection, then I get everything in my JSON Web Token. To get a data chunk, this is the same thing. It happens each time your clients want to retrieve some content or a third-party application asked to get access to a content inside shared by another user. So when you want to serve some part of data, you just read your item collections. If there is no item, you return an error. If the item recipient is not the requested users, then you throw an error. It ensures that a user that is not allowed to access to a part of data can't access it directly on the backend. If you check the expiration time, if the payload is expired, you won't serve it. And you check the signature by itself to be sure that it wasn't altered directly in your backend storage, in your MongoDB or so or otherwise. And you return it if all the conditions are on. Simple bonus point. What about the zero-knowledge proof? It's an authentication system, an authentication pattern. Let's say I'm a third-party application and I want to access some user's data. I first ask, as a third application, the right permission to access the data to the user, then the user accepts it, and then the user is able to share a blob of data with me. Okay? So the first thing is to put a request in the recipients list of the users to ask for permission, then get a JSON Web Token, updating this Web Token with my own private key signature to ensure I'm allowed to perform some kind of request on the user's data. Then this token is pushed to the user, and the user can then put some data flagged with the right recipient UID. So finally, this is just a simple REST ping pong between your clients and your backend. That's all. It's not that complex, at least on the backend side. At least on the backend side. Because it's mostly a REST API with some crypto sugar. You just do some signature verifications, some expiration verifications, and that's all. For the rest, this is just storage. and this is just a REST API. Because your tools that you want to rely on the backend part is mainly the JSON web tokens, the signatures, and the dead time tokens. The complex part is on the client side, and it requires a lot of cryptography. And if you want to talk about zero-knowledge architecture, I'm here and I can discuss about it as much as you want, really. But the complex part is on the client. Let your developers to work on the same library that is used in the backend and in the front end to be sure that any part of the cryptography part is properly handled. That's all from me. I'm Mads. I'm a tech evangelist and a little bit paranoid at Always Data, which is a PaaS provider, and we are looking a lot of what our clients are putting online, and we're advocating a lot about security and zero-knowledge architecture, and we do some experiments with Node.js on the backend part. If you've got some questions, I'm here during the rest of the conference and the party, so come to me and let's discuss. With great pleasure. So sorry again for my voice, and I hope this helped you to understand a little bit more about zero knowledge and backends. Thank you very much.